A coffee cup falls and shatters. We've all seen it. What we never see is the reverse, the shards leaping off the floor and reassembling into a cup. The reason for that asymmetry is the most important idea in physics. It's called entropy. And the way it's usually explained, entropy equals disorder, is, at best, half right. You've probably heard entropy is disorder. A messy desk has more entropy than a tidy one. A pile of bricks has more entropy than a tower of bricks. That intuition isn't useless, but it sneaks an assumption in that someone is comparing your room to a tidy template. The universe doesn't have a tidy template, so we need a sharper definition. Take a fresh deck of cards, brand new. There's exactly one arrangement, ace through king of each suit, in order. Now shuffle it. The number of possible shuffles is 52 factorial, about 8 times 10 to the 67th. Pull any random shuffle out of a hat, the chance that it's perfectly sorted. Roughly 1 in 8 times 10 to the 67th, effectively 0. But here's the trick, the chance that any specific shuffled deck happens. Also 1 in 8 times 10 to the 67th. So why does sorting feel special and a shuffle feel boring? Because there are stupendously more arrangements that look random than arrangements that look sorted. Entropy is just a counting question. How many ways can the system look the way it does? 2 key words. The microstate is the exact arrangement, every card in its precise spot. The macrostate is what you see from outside, sorted or shuffled, or all spades on top. A macrostate has high entropy if many microstates fit it. Low entropy if only a few do. Sorted is 1 microstate. Shuffled is something like 10 to the 67th. There's a formula for this. It was carved on Ludwig Boltzmann's tombstone. S equals K times the logarithm of W. S is entropy. W is the number of microstates that look like the macrostate you observe. The bigger W, the bigger the entropy. That's it. That's the whole concept. Now we can rewrite the second law of thermodynamics without using the word disorder. Imagine all the air molecules in this room compressed into one corner. There are very few microstates that look like that, so that macrostate has tiny w. Release them, and a fraction of a second later they're spread evenly. There are vastly more microstates that look spread out, so spread out has gigantic w. The system didn't prefer to spread. There were just way more ways to be spread than to be compact. The second law isn't a deep cosmic preference, it's just statistics. Which brings us to time. Why does the universe have an arrow? Why is the past different from the future? Because the universe started in a freakishly improbable, freakishly low W state. The Big Bang was the most ordered moment in history, and there's been nowhere to go but up. The arrow of time is the gradient of entropy. The reason your coffee cup never reassembles isn't that physics forbids it. It's that the number of microstates that look like a cup is unimaginably smaller than the number that look like a puddle. Time, broken eggs, melting ice, the heat death of the universe, all of it, from counting.